Okay, so we'll go ahead and get started. Today we're gonna do a little bit different lab than when I taught it last time. Uh, Last year when I taught this chapter, we actually used Security Onion, which I tried several times with different classes to see how they work out. But students seem to struggle with Security Onion. That's the process for the installation is really long. However, this industry suggests that you use Linux virtual machine or something like Security Onion. So if you're interested, I do have instruction on how to install the Security Onion, or you can go to their website. Their documentation is generally pretty good. There's some fixes with CentOS, so it uses CentOS version 7. So today we're going to use Kali and Kali's tool. So to start, we're going to go over chapter 5, which talks about investigation and process, and then we will talk a little bit more about some of the forensic tools that you would see for digital forensic, and then we will use, so we're going to need, one of those. We are going to use some of these tools down the line, so I'll touch back on the tools. But today we're gonna do imaging and a little bit of analysis. So ideally, if you have a small flash drive, it is gonna be faster than if you have a terabyte or more than 4 gigs. Okay, so in the first part, it goes over the investigation process. And this is a way that we would go through and looking at what you're searching for. It's really important that you have an idea or a goal on your objective on what you're looking for as far as artifacts for your evidence. So your scope is very important and you need to identify that right off the bat. And then in the case where if it's for litigation, you see that judicial authority require digital evidence in a certain way. So there's limitations in the timeline that we would have or how we would represent the timeline or doing timeline analysis. And so when we do timeline analysis and some software tool, you're going to see some of that today. I'll point that out on Autopsy. Down the line, we're going to use Windows version of Autopsy. Today, we're going to do Linux Autopsy. Or Autopsy on Linux browser, but it is browser oriented, so you can run it on the browser itself. But when you do timeline analysis, basically you're creating a timeline for the event or the occurrences that took place based on your evidence. Okay, so you're trying to piece together the story of what had happened, how it happened, and who did it. So in this case, what we want is in digital forensic or in computer forensic, we generally looking at MAC times or MAC times. This is when it was modified, when it was accessed, and when it was created and what was created. So we're looking at the times based on the occurrences of the records timestamp, right, of the file system on how the files were created, edited, and accessed. So it's really important that you know MAC times because you will need this for your course project down the line. And then as you go through and do some exercises in our lab, it's important that you put together a whole story based on the timeline. So in the context, you will use some tools or sources to provide that information. So some areas that you want to look at, event logs, right? Your computer event logs like event viewer in Windows system or in log files for Linux systems and other type of system. And then when we saw a little bit of this in ProDiscover gives you the timeline layout also. So your file system logs, it tells you the MAC times, when it was created, edited, or modified and accessed. So that's different, right? So I can create a file today, and then I will go back tomorrow and modify that file. And then down the line, 2 weeks from now, I can open the file, which is access, right? So when they simply just read the file, it shows that it is access, or if the file is used by another application, right, but not modified. So whenever that you have modified, there's some changes that occur. And then when you create, that's create new. So your file system capture all of that, and that's through your operating system. And so in the small details, we have to understand the difference between these three elements. Okay. Okay, so let's go through and answer the questions. Sorry. So MAC times refer to modified access and created times. And these are records created by your file system. And we learned in the prior chapters that Windows have different file systems than Linux, than Apple systems. So when you're looking at the platform of the computing system, right, the operating system is a way that the human can interface with the actual computer to be able to use the files or create the file or modify the file. So through the operating system, we see that the file system, right, the files have timestamps on when they were created, who created them, right? Whether there's an application that's involved, and then also who edited, when it was edited, and when it was accessed. Why is this important? It is important because it's part of the process that's going to provide you a timeline of what has occurred. Because forensic is really after the fact. We're going back and we're trying to put together a bigger picture of what had happened, right? Based on file information, system information, maybe email, headers, or, internet searches and so on. Now, for the resources that we can use to determine the context of what had occurred to specific artifacts, we would use event logs, your file system logs, internet history, like internet searches history, and sometimes even email. I didn't include that in the answer, but when you later on, we would also look at email, social media, and other elements. But overall, that's going to give you maybe what had occurred. And it could be all in one day or an hour or within the hour or over several days and months and years. And as you look at the timeline, sometimes we would see that there might be some missing artifacts because, if we're looking for a missing person and we have their iPhone and we only were able to find a few things, that doesn't always tell us the whole entire picture. So the more artifacts that you can obtain to be able to give you the MAC time, that's gonna be more relevant or more of a concrete story to tell for your report. Any question regarding MAC? Make sure we know this for quiz and final. And then if you're going for forensic certification, this is really important. And then in the next part, I think most of the notes today kind of cover some of the technical tools. They are relevant to this part of the industry, right? So as you go through, you would look down, and I think I mentioned X-ways in the prior chapter, but I also put a link for you in case you're interested in looking into using this tool. But please read the documentation. I think I wrote a lab for X-way, so we'll come back and use this tool down the line, right, with an image. But starting today or since last week, right, you already know how to create some images using Windows. So today we're going to create a USB image using Linux. And so you can test it using your own image, and you can use a micro SD. It doesn't have to be a USB, so any storage drive will do. So for X-ray forensic, it has a feature where you can create a timeline. So as it pulls data, it's going to organize it for you into a timeline perspective. So you can see like what goes before, because if we do this manually, it can take a lot of time. So you have to isolate some of the artifacts and then be able to look at, you know, how it logically lay out based on the time. And if you're looking at malware, sometimes it takes seconds, right? Or minutes to get across the network. So, you know, it can be very quick. And then sometimes we would have timeline that's longer. So it uses what's called an event list. And it basically look at the timestamp from the file level, also browsing history. We touch on that, event logs. Registry hives, this is particularly for Windows PC. We'll come back to this. We're going to spend a week on this a little bit, but you're going to hear a lot of that in forensic. Registry is a database that contains hardware and software information for the operating system in Windows. So whenever that you are installing a new software application, it updates that. When you add a new device, let's say even a plug and play or Bluetooth, it updates that. So we can also go into registry hives, and X-Way has the component for that. And it's the cool part is these software chronologically lay everything out for you. Otherwise, you have to do it manually. Okay. So this is like a screenshot that was provided by the author, but you can also go to their website and look at some of the example information. Okay. And so when we do this manually, we have to use something like a spreadsheet, like a list to kind of keep us organized, but the software itself has that information or that component. I'm sorry. Okay. So let's answer the question about X-ways. So when using X-ways in forensic investigation, which feature should you use to establish the timeline for artifacts? We're going to use a thing called event list. And if you're using X-ways, right, before we approach it, we want to see how we install it, how we use, what's the system requirement, and whether it will work with our current image, what type of image format that it will take, and so on. And when you're using it, if you're searching for an event with a specific date and time, we simply access event list feature. And on it, you would click the calendar, and then you can filter it out based on the date that you're looking for. So for example, if I'm looking back October 10, 2023, last year, or maybe another time, right? I just simply click on the calendar and select that date. And we can also filter down to the file name. If you know exactly what the file name would be, you would specify it. And most forensic software, you can use the asterisk as a wildcard to include everything that's related. So for example, if I'm looking for like documents, I might want to use *.doc or docx or .pdf or .jpeg. So you can search for the file name if you know the file name, and sometimes we don't. A lot of the time in forensic, we're pretty blindsided, or we're blind going into the investigation. So we can just examine what had occurred. And sometimes you have a range of dates, right? We know that the event occurred during that week or that month. So you have to take the time to go through and examine it based on the range. So you can select the date in the event feature. Event list feature. Any question? So that's X ways. I think we mentioned it last week, and then we're gonna we talk about it again this week, and we'll use it down the line. And some forensic software are easier to use than others. You have a little bit of experience with ProDiscover. It's pretty user friendly. And then today you're gonna look at Autopsy. Those are very common free tools that you see. And then some of them are just command line based. So you have to see what kind of option you would use in order to be able to evaluate it. And speaking of command line based, Plaso is more of like a toolkit, and it's using only command line. So you have to be able to use, right, the similar to terminal commands to be able to execute things. So before you approach it, go look up the documentation, and you know they would have instruction for you to use on what type of command. And then most of these tools are built for Linux systems, so you can always use the -H option for help, and it's going to give you the help man page or manual page to be able to see what options you should include with specific commands. And the tools, and you can visit the site to find out more information. It consists of image export, creating an image and then bringing it out to another storage. We saw that in ProDiscover and other tools. And then log2 timeline is very close to what you see from the above tool, is that it evaluates the logs and then it's going to lay out the timeline for you. And then you have the p-info and p-sort and p-steal. So these are function that's going to give you information, sort to be able to organize your results, and then p-steal. So I'm going to come back to Plaso in another lab. I wrote a lab for it. The problem with open source tool is sometimes, you know, we have to change up. So even if you use it one time, the next time you use it, maybe next year or down the line, make sure you go back and test it, because developer, they changed up their packages. So I find that sometimes functions stop working, and then because they create a new function, for example, like p-steal, right? That stopped working, and then if you use it again, you have to, use it with another options, or they change up the menu options. So we got to go back and retest it before we use it. So how can I use it to really output something for this command? So this is an example for you to look at when you're using Plaso. So in Plaso, what you can do is you can use its feature, which is log2 timeline. And you are going to use a -F and you are going to filter down this, or I'm sorry, to access the file. The F is for the file, and this is the file that we're using. And what we're going to do is we're going to specify the path, right? And then the image path. So the result is going to go into here, and it's going to access the image to evaluate for that file. Okay. So you can simply use an option. In this case, we use a file option. So when you're using this command, it's going to use log2 timeline command to extract this file, the filter windows text file, right? And the destination, we're gonna put it into the genefilter.plaso, and it's gonna find it from the image gene 001. So you want to put your destination path before your source path. Just a little bit of practice. And this is done in command line or terminal. Now, most of the tools out there have command line interface. Basically, it has its own command list. And so when you call on the application, after that, you just execute the command that it accepts. And in the back, it would run that function to be able to pull the file for you. So in this case, we're able to locate the file from the image and then place it into our application file, genefilter.plaso. Now, you might not remember this down the line, like how to use it, right? Like I said, documentation for the application is there. You can always go in, or you can use the help option in command line. So some example for email header, we will evaluate email down the line. So you see email header just usually contain who is it sending from, where is it going to, subject line. A lot of the times it also sends some data or payload information, like attachment, the type of attachment files that it comes with, or even the size. So that can be of importance in malware aspect, or in when we're looking at, you know, fraudulent cases or communication type of cases. And then sometime we want to look at deleted files. Also prefetch files. The prefetch files, those are, you know, like the files are set up, but it doesn't go into access yet. And then also cookies. A lot of websites now use cookies for marketing purposes, so they gather your data that way. So a lot of the times that's already used in the back, and so that's gonna correlate. We can correlate some cookie information with the history, but cookies can also give us access information as well. Okay. So here are some of the suites, right? I mentioned autopsy. We're going to use that today. Recon lab. I think I wrote a lab for this, but you can look at the Recon lab information from the website. I actually created Paladin USB. So this is a live USB type of Linux. You just plug the USB in and you start your system and it boots. I have some. And I tested the lab here. We had a little bit of challenge in booting USB on these PC because they disabled that, but you can definitely create it. I didn't like the Linux interface that they have. The tools that they have are cool, but it's kind of hard to navigate it, in my opinion. But you can definitely watch their tutorial videos on the website if you're interested. And then Plaso information is here. So the timeline that we talk about, that's one of the important features that you can use from this particular software. Okay. And then psort, pseal information is like that, and then some screenshot. And there are a lot of other options that you can find. So the layout for this, right? Like this is that's what went into your questions. Command, they say modifier, but I always learn Linux. That is an option to your command. That's like, it branches off to how it's gonna seek. or access, and then the source and the destination. I think they have this backwards because I tested the command that I wrote for you and that worked on CLI right here. Okay. I think this one is written in Python. So if that's the case, usually they write an API so you can grab it and then use it with another set of tools or another tool, another application. And then you can output and you can specify how you want to output your results. That's important because, you know, sometimes we want to put it into a database, like using JSON, or sometimes we want to put it into like XLS, you know, or something CSV. A lot of times when we do data analysis, CSV is important. Comma separated, right? Okay. All right, we talked about number 6. I'm gonna go into number 7. So the tool that you can use to get the storage information like Drive, right? Anywhere that they would store the data, where that file is stored and how many sessions were used to create it, you can use pinfo. Pinfo is going to give you the storage information that stores that file that you're looking for and how many sessions for creation. Now, when you're using psort, this is a way that we can have it output. So we can say out with an option O with the format. Basically, your format is going to be how your file, the type of file that you want, or, you know, how you want your, sometimes it also allow you to display a certain way. So onto command line, display text. Okay, so because when you run, you saw the screenshot, it's kind of like mumbo jumbo everywhere. So all the text is kind of laid in together. So that can be very hard to see. So you can organize how you want your display or your file output to be. So some of the tools that we can use to really lay out the timeline outside of the ones that we talked about would be your time sketch, Timeline Explorer, Timeline Maker Pro, and then there are others. And so outside of, let's say that I don't want to use Plus-O because it's CLI, or I prefer to use another tool, there are optional tools that you can look at. And these changes over time too. So down the line, you would see additional tools and then some open source tool. They might become proprietary, you know, just to have the maintenance behind it. Development is expensive, so, you know, people want to get paid for their software engineering work. So it's usually a lot of the times when you see a good software, eventually, like Pro Discover, you know, if you go and try to find the latest version, you have to pay for it. The version that you had used on your virtual machine is an older version, which it was freely available. But now if you're trying to go, and then sometimes you know, even if you find a download link that's legitimate, it is very difficult to find. So these free software becomes proprietary. They charge for it per license. Any questions? Our notes are kind of short today. You know, there's not too much. And then our lab, just the longest part is the scan. So. So when you're looking at storage media, because it contains data, right? Your files. So that could be micro SD, USB, internal drives like SSD or HDD. We touched on, the drive last week. So when you're looking at storage in general, you want to look at allocated, unallocated, slack, and bad sector space. So allocated, that means that it utilized that for the formatted space. Unallocated just means space that the drive still has, but it's not dedicated to any format yet. So for example, if I have 100 GB drive and I use half of it, which is 50 gig, for NTFS format or that type of file system. So I should have 50%, a little bit less than 50% that is unallocated. And that's different than free space, okay? Now, the slack space, we talked about that last time, is when you delete a file or when the system gives back that space, right, to the storage and it becomes available for the new things that could be added, that becomes a slack space. And then sometimes you also can discover file on bad sector space. So we know that each of the sector can be a group of sectors can be part of the cluster, which your files can span across. So your files can be in various sectors. And sometimes it can also write part of your file onto a bad sector space. So, and some software is really good at looking at that as well. You see some of that with Autopsy, but it doesn't always guarantee with the software. So some software you have to manually tell it that you are looking at these sections. So the drive, we want to look at like the formatted space, the space that's not used for format yet, and then the slack and the bad sector space. And we'll come back to some of this when we do file carving. You did some of that last time with Pro Discover, but we'll get more in depth with it. Any question? So how can I find this information, right? So all of that after your plateau details. I want to touch a little bit on this. Whenever that you do data analysis in using logs, Elastic, Logstash, and EOK, Kibana is the K. I think one of the three actually went proprietary recently, and I try to use this for my my analyst class, and that kind of didn't work out because you have to pay in order to use the third part. But when you pulling data from logs, EOK is such a good tool in the field for that. There are a lot of other software that uses its component because the open source code that's available. And then you would see, I put some link for you to look at. There's also Eon Timeline and others, so you can find more. And then the bad sector, slack space, and unallocated space is located there, and it is on page 10. And for the progression, so how do you evaluate a disk or a media? You would start with the physical device like drives, SSD. Sometimes we look at RAM, and we'll talk about volatile storage later. But for disk, we want to look at the physical storage devices. Then we look at it as a container, what it stores. So think of it like you are examining a house, right? From the outside, its physical location on Earth. in that city, in that town. Then you would see, the volume, the size of the house and what's inside that house, how many rooms and what's inside the rooms. So as we go from the outside in, we're going to look at what's it contained inside that storage device. And then we're going to break it down to the data unit. Usually you would see this, looking at blocks and sector, and how it breaks it down to like 512 bytes. I think we saw a little bit of that, how it uses the address where it's sectioned up your file. So the progression in storage media examination, we have disk volume, file system, data, and metadata. So metadata are text, or it could also give you attributes of the file itself, right? So we're gonna go from the physical disk, the outside, remember the outside in, the volume, what it contains, and then the file system that it uses, NTFS, FAT. It could also be Linux-based type of file system or other like Apple. And then the content, right? So we're looking at as a container, the type of container, and then the content, and then the attributes of that content, which is the metadata. And metadata can tell you things like geolocations, right? Especially if you're looking at things that are image-based or picture-based. And when we're trying to narrow down actual data, it's probably good to do keyword search or text-based search. As human, we want to tell the computer what we're looking for. So what you can do is, a lot of the software, it would say keyword search. So when you type in that keyword, it puts it into quotation mark, which is a string, and it plugs that into a function and it executes it. So today, when you're doing autopsy, at the end, I wrote down that you can search for things like social security number, which is a predefined keyword, or you can also filter out however you want to look at. So let's say that I want to look at an event that occurred. I'm doing an investigation like that line fire case, right? Like I want my keyword to have significance to that case, right? So we want to make sure that our keyword is applied. So you can use generic keyword lists, but a lot of times it's probably ideal for you to have or customize a list. But most application will come with a keyword search list. And then you can also do case specific keyword list. So you can create a list and then you can plug that in. And it will search based on that list. It will just go down from the first keyword all the way to the end. And so the longer your keyword list, right, the longer it's going to search, but it's going to help you narrow down more in the results. And I think that's important. In security, the word list is so important to us in many areas, right? In forensic, and then if you're looking at like brute force or dictionary attack, they all use a certain type of word list. So the more comprehensive your list, right, the more execution that your system is going to go through, or enumeration or whatever, right? So it's important that you think about your keyword list and expand or customize your list. So when you're using character in the search, when you place any character in a search, you are going to use the dot or the period. Okay. So this is the symbol that you would use. And when we do autopsy on Windows, you're going to see more of it, and you see some of it today, but it's more, we're using a predefined word. When we do autopsy again in Windows, you see it. Any question? We're just whipping through this in less than an hour, right? Okay. So here's information for string search that we went over in keyword list. That's on page 11. Now, some of the things that you need to kind of see, and I didn't put this into the questions, you see this with forensic software and you see it with the one we're using today. And I know most of you know this if you're taking programming classes, but all your application uses some form of encoding. This is the way that it would use text-based type of characters to be able to apply that to the application. So the common encoding scheme you would see is either ASCII or Unicode, right? And with that, you would see some application would implement symbols that we can use to kind of find a pattern. In forensic, it's important that you have some kind of pattern. We need to recognize the pattern because we might need that for many files or, many artifacts. So the wildcard, the asterisk symbol, we can use that preceding, it would match anything preceding it, right? So for example, if I'm looking for cat, C-A-T, I can do C-A asterisk T, but it can also place other characters in between. So something close to what you're searching for, you can use the asterisk symbol, right? The book called this the pound sign, but it's actually hashtag, right? This allows you to match numerical value 0 through 9. And then you just need to use the backslash. And then you can use the caret for the start of the text. And this is common with a lot of the forensic tool. The $sign, you can do that to match the end of the text. So like $1, $2, $3. And that could be like a positive, a plus number, some additional character. So it would end with 1, 2, 3 there. And then we can use plus symbols. So it goes on. So I give you this list. So in case you need to reference it down the line, and here's our question. The dot can take place of any character. It is also a wildcard. Okay. Now, the reason why it's this is because regular expression is applied in a lot of different applications. So when I taught programming for the upper classes, like 17C, 18C, I encourage them to use regular expression. It is a way that we can control how the data comes into the application. So we have cleaner data. And also in security, we really look at regular expression so that way we can control, code injection. So, you want to control the number of digits that they can input, the characters that they input. For example, like you can't use certain character in your password on some of the application, right? So we can specify that with regular expression, but regular expression can also help us find pattern like IP addresses and so on. So you see a lot of this being applied and simply, adding the expressions like on like social security number, how many digits you want. So I can say 3 digits in the front, 2 digits in the middle, and then 4 digits in the back. And I just apply that with the regular expression. And if you take JavaScript, they might have gone over this. When I taught JavaScript, this was included. It's very important. Okay. Okay, so for 14, how do you find deleted files on NTFS volume? And NTFS is the file system for Windows, right? Windows 10, 11, or since 7, and also NT prior. NTFS give us encryption capability, compression capability, right? Permission-based control. So Microsoft continue to use NTFS, NT file system. So if you need to find deleted files inside that volume, you would locate it under MFT file entry. So it puts it into an unallocated cluster. And it's going to increment up from 1. So you saw a little bit of this last time, right? Remember, you click on deleted files and it shows how many files were deleted. And then you looked at the files in black and you saw a little kitty and the smoking gun, right? So what you did there was, but you looked at the FAT volume instead of an NTFS volume. Very similar to it. However, it throws it back into an unused space. Okay, so this is why we need to look into an unallocated cluster. Basically, a cluster on that disk that is not being utilized by the file system or the format yet, right? Unallocated space. So recovering deleted data. So we saw the FAT, the FAT file system. And so you would look at, and this looked familiar, like last week when we did the lab, we would see, and here it tells you that you would you would see from the hex E5, and you would start with the entry 00. Remember how we calculate the byte size from one to the next, right? So we would start with the 00, and then we would increment up depending on how big that file can span across the cluster. So we would start with cluster 00, and then we would expand it. So in this case, it goes up to hex 08, which is right here. See how that's blue? Okay, that shows you the file entry or the directory entry. That means that exists with the folder, the container for that file. So here it says that it occupies one single cluster on the FAT, and the entry for it is on cluster 8, right? Because it's 0 out. So that means that it only used that one cluster for the file. Everything else is blank, is null. And then on the deleted FAT, you need to look at from hex 00, and then it goes all the way to FFF8. Here's the NTFS information that we put down. So when you delete a file, right, it puts that dollar symbol in the front. That makes that cluster becomes unallocated for later use. It would make it available for the new files to come in and use that space, right? So this is just a way that the file system handle the file that was previously stored there on those clusters. Now, if you delete the directory, it's going to be very similar to that. So if I delete a folder, okay, and the subsequent files, it's going to be in the file headers record, and it's just going to increment up 1, 2, 3, 4, 5, and so on. I think that's basically the end of that. So 14, after that, you just log in, save your work, and then log in and submit. Make sure we save our answers and we submit the document that has the answer. I'm gonna stop recording.